ideal gas. So, unsa ni siyang ideal gas? Meaning ideal kining kuan siya. Kining na mga assumption niya. No? Nga nindot diba kami yung tag-ideal kanang atong gipangarap, no? Ideal person or ideal kining someone. Not here we have ideal gas. So for ideal gas, we have this equation of state. This the very known equation. PV is equals to RT. Can you see my screen? Okay. So pwede po na siya. This is PV MRT, right? Now your V here muna siyang na PV MRT is PV is equals to RT because with this in our previous discussion, V is small v, which is the specific volume, is equivalent to V, capital V over M. So the unit of this is cubic meter per kilomole. And you have this R. Saan na siyang R? You have the universal constant. This is your universal constant. And you have this value 8.3144 kilojoule per kilomole Kelvin. And your R is the specific gas constant. Okay, so this is R bar over the molecular weight. The molecular weight this is kilojoule per kilogram Kelvin. So this MW is your molecular weight. So you can write also the V bar. Here this is the molar specific volume. So wherein you can write, or this V bar here, this is equivalent to V over the N, where your N is the number of molecules. So therefore we can write the equation of state as PV is nRT, now referring to N as the number of molecules. Okay. Nanis siya sa atong chemistry na. So try to review. What is Boyle's law? Nasa man siyang Boyle's law and Charles' law. Anyone? Anyone? Si Kisto. Pardon? What is Boyle's law? Unsa equation aning Boyle's law and Charles' law, unsa yung assumption? How about Mark Jason Bote? P1 plus P2 is equals to B1. Ano na? P1 nasa chat. Itong tanawon. P1 plus P2 is equivalent to V1 plus V2. Ano sa na siya? Charles o Boyle's? So remember that we have this equation, the P1 B1 over T1. This is equivalent to P2 V2 over T2 sa atong chemistry na. Okay. If your mass, given that your mass is constant, given a process. Okay. So the for example, if you have the temperature as held as constant, if T is constant, you have P1 B1 P2 V2. Okay, and if the volume is constant, we have P1 over T1, P2 over T2. Muna siya. Okay? Okay. So you have called also you have this Z as the compressibility factor. Wherein Z, this is equivalent to PV over RT, or P V bar, this is R bar T. So we have this one. This mixture of liquid and vapor, meaning that it's saturated. So this is at 300 Kelvin. Kelvin. So this is 1.0. This is your Z here, where Z is PV over RT. So then this is your pressure. This one, this is 8 and 10, 20 and 40. Okay, so at P is equal to 0, or as P approaches to 0, then your Z here, or your compressibility factor, is equal to 1. So at 4 megapascal, your Z is lesser than 1. pressure megapascal. As temperature is reduced. Okay, actual actual density is greater than. And this would be predicted as ideal gas. So you can write the ideal gas as here P over the density is equivalent to R over T, R times T. So your density here is P over RT. Okay, so at very very high pressure, your Z is greater than 1. So in order nga ang imong Z is greater than 1, your density should be low. You have low densities. So in your module there is the chart there, the generalized compressibility chart. Okay, so nga naman ano, this is your Z, this is P V over RT. We have the PR, which is the reduced pressure, and TR, the reduced temperature. So this would be your PR is given P over P critical. This This is critical pressure. And your TR, this is T over TC. This is your TC is your critical temperature. Okay. Any question? Will a question? So let's proceed. Para mas masabtan mga atong gatagtag example, no? For example, natay spherical balloon. That contains air. It's your spherical elastic balloon. So you have the relation, this is your B, and your spherical balloon has a relation that P, the pressure at B is directly proportional to the diameter of your balloon. So then you have a bulb here. This is your air here. your tank A. Example, this is a rigid tank. So you have given volume of A. This is 0.1 cubic meter, and the pressure of A is 300 kilopascal. And we have the temperature of A. This is 25 degrees Celsius. Given that the temperature of A or B is equivalent to temperature of your A. Okay, so initially you have a rigid tank which contains air, and this is your valve. As the valve opens, so your balloon will be filled with air. So the relationship between the pressure and the diameter is you have the pressure is directly proportional to the diameter of your balloon. So if the pressure is the pressure will increase, so the diameter of the balloon also will increase, because this is an elastic balloon. Okay, but of course it has a limit, because when the pressure is too high, so mabutong po na yung balon, no? Yan naman na siya elastic limit. So we will find now what is the pressure at 2. Okay, so pila ang pressure dere? As the valve opens, so this one you have the diameter of your balloon at state 1. This is 0.5 meter, and the pressure at state 1 is 100 kilopascal, and we have here the 25 degrees Celsius. Okay, so as the valve opens, so the pressure will what? As we analyze our system, and the valve opens, so may quit ang imong pressure dira na. Your pressure at your rigid tank A and pressure and of your balloon is equal, right? There is equal. You know, as you open the valve, may equal na siya. Now, what is that pressure? Unsa na siya nga pressure? So we will solve. We have our solution. First, we will now solve for the mass of your A. at state 1, this is P A V A, state 1, over R A T A 1. So this is 300 kilopascal times 0.1 cubic meter. So over R is 0.287. This is in kilojoule per kilogram Kelvin. Times this is 25 plus 273.15. So the mass of your rigid tank A at state 1, this is 0.3505 kilogram. Okay, at your mass, at the mass of your B must be here at 0.1. This is PB 1 VB 1 over R B and T V1. So we have the given pressure, that is 100 kilopascal, and we have this diameter, that is 0.5. So if that is the spherical balloon, so the volume of the sphere is what is the formula for the volume of sphere? The volume of the sphere is pi d cube over 6, right? Okay, so that is pi d cube over 6, volume of the sphere. So that is the volume of your B1. So this is pi, given the diameter, that is 0.5. Cube over 6. This is all over 0.287 times, what is your temperature? This 25 degrees Celsius time plus 273.15. Okay, so we have the mass of your MB1 is that is 0.427 kilogram. Okay, so take note that as you open the bulb, or we can have the mass 2. That's mass at state 2, wherein you open the bulb and also the pressure is equal. So your mass 2, this is equal to mass 1 equal lang siya sa mass 1, diba? This is M A2 plus M B2, and this is equal to pila mass of Ma is this is wrong. This is the mass of your here this is 0.0765 kilogram. So your mass 1 here, this is M1 is, this is MA1 plus MB1, this 0.3505 plus 0.0765. So your M1 here, your M1 is 0.4. Your M1 is 0.4. 0.427 kilogram. Okay. 0.427 kilogram. So since you're after the how to calculate or to determine the P2, so here we have the P2 V2 over R T2. This is M, right? This is M2, and this is equivalent to 0.427 kilogram. So we have this assumption, or we have this condition, P2 is equivalent to PA2, and this is equivalent to PB2. And we have the temperature A2 is equivalent to temperature B2. This is equivalent to T2. And the volume V2 here, this is the volume of your tank at A2 at state 2 plus the volume of your balloon at state 2. Okay, so now we will substitute this one to this equation. So we have P2, this is VA2 plus VB2, this is equivalent to 0.427 kilogram. Times the R, that is 0.287 kilojoule per kilogram Kelvin, times what is the temperature? The temperature is 25 plus 273.15. You add 273.15 to convert the degree Celsius into Kelvin. Okay, so you have this equation here, that P2 is V A2 plus V B2. This is equivalent to 0.427 times 0.287 times 298.15, that is 36.547. Okay, and we have the relationship between the pressure and the diameter. That is P B is directly proportional to your diameter P. Okay, and that is VB one-third. Okay, so we have this VB this is dB cube, or VB one-third is dB. Okay, so we have that one, the relationship. So we have now PB over VB one-third. This is constant. Okay, or you can write this one as PB VB negative one-third is equals to constant. Therefore, we have that relation, that the PV to the N is constant, where N is negative one-third. Okay, so therefore, by that relationship, we have the P2 VB 2 negative one-third is equivalent to P B1 V B1 negative one-third. This is constant. Therefore, your volume B at state 2 is equivalent to VB1 times the pressure P B1 over P B2 this is 3. And this is negative 3. Okay. Positive. Okay. So what is VB1? That is pi times the diameter 0.5 cube over 6 times the P2 here over 100. This is raised to the power of 3. Okay. V B2. So we have two equations to announce. This is your first equation here. This one. And this is your first equation. And you can substitute the volume of A2. Since this is a rigid tank, we have a rigid tank, meaning the volume at any state is constant because it is a rigid tank. So you can substitute the VA2 is equals to 0.1. Have two. This is your first equation. So you substitute the 0.1 meter cube here, and this one is your second equation. So you can by the power of your calculator, or you can solve by manual or trial and error. So you have the VB2, you have two equations to announce, so therefore you can check that the pressure, the final pressure of our system is 136.7 kilopascal. 136.7 kilopascal. Let's check our answer. Just going to analyze this one. So you have the B2 100 pressure 2. This is 136.7 kilopascal. So initially this is 100, and initially this is 300 kilopascal of your rigid tank A. So as you open the valve, the pressure of your rigid tank A and the pressure of your balloon at state 2 is equal. So you have the range here. (100 to) that is your 100 and this is your 300. So as you open the valve, okay, so your pressure should be lower than 300, okay, and your pressure also should be greater than 100. Okay, your pressure 2 is lesser than 300 and this is greater than 100 kilopascal. So since our answer is 136, that is reasonable. So by checking, 136.7 is within the range of 100 to 300 kilopascal. So air is considered, we have that equation because air is considered as an ideal gas. Okay, so yun na, diba? It's easy. Any question?